I'd like to welcome everybody to the Electric Education Center session number 6. This vlog will talk about generators and specifically optional standby systems. These optional standby systems, basically there's a Article 445 that will explain some of the rules for generators. It's going to require that they be listed and labeled by somebody like UL or Intertech or CSA. And the equipment has to be approved by some nationally ranked testing laboratory. Where are you going to locate this generator? The Article 445 says, hey, give us some room for to be away from combustibles, and also give us some room in case we have to perform some maintenance. It'll talk about the overcurrent protection, the ampacity of the conductors. Ampacity is two words put together. That is ampere capacity. That means how much current a wire can carry. So that's what we're going to talk about there, at ampacity of conductors. Disconnecting means is in that article. Emergency shutdown means is now required in the new 2020 NEC. There's a rule requiring an outside of the building, an outside and readily accessible emergency shutdown for these generators that are other than the plug-in type of generators. And we'll show you a picture. There's something that I recommend you start installing now, and that's these emergency shutoffs. As long as you know it's on the way, it's going to be required in the 2020 NEC. Why wait? I would also recommend that you recommend to your customers that their existing installations should have an emergency outdoor readily accessible shutoff switch installed. A lot of these generators are coming with this new emergency requirement already. They're coming with them installed, I understand. So when you're talking about these generators, you want to get into the correct article. Article 695 is for generators for fire pumps. Article 700, emergency systems like hospitals and healthcare facilities. 701, legally required systems like lighting, ventilation, and heating for an office building. Article 705 is for interconnected systems like the solar, the windmill production, DC microgrids. These systems can all operate in parallel with the utility. Microgrids are a rather recent addition to the NEC, and basically what they're all about is mainly creating DC, storing it, and using it without ever changing it back into AC. So that's the microgrids, brand new article in the National Electrical Code. Article 702 is what we're going to be talking about today. And Article 702 is the optional standby systems, optional. So the size we're talking about is basically in the 15 to 22 kW range, and generators like Kohler and Generac that would be installed at a dwelling unit. So here you see basically two types of standby systems, portable and stationary, that we would use at a 1 and 2 family dwelling unit. These optional standby systems, they would supply power to public or private facilities. They're not really a life safety type of a deal. The supply can be automatic or manual transfer to serve the building, and they could be used for heating, refrigeration, communications, some industrial processes, and residences, 1 and 2 family dwellings. All right, part 1, deciding on a location to put this 22 kW or 15 kW generator. Do you want to have a stationary one, or do you want to have a portable one that you roll out of your garage or your shed? Do you want to put it indoors, outdoors? What about ventilation, carbon monoxide? Well, these units don't lend themselves to indoor installation. Matter of fact, there was not too long ago, a fella that didn't know better was running a generator in the basement of his row home, and the buildings were filling up with carbon monoxide, and 12 people went to the hospital. Thankfully, nobody died. But I thought when you were overcome by carbon monoxide, all you would have to do is go outside, huff some fresh air, and then you're okay. Well, that's not the situation. When you get this carbon monoxide in your bloodstream, the only way to get it out is at the hospital. So don't play around with somebody that's been overcome by carbon monoxide. So outdoors, where do we put it? How close to the building? What wall openings do we have to deal with? What about noise? Is there municipal limits on the exercise time and how much noise these units can make? What about the environment? Are there diesel emission limitation times? Are there special municipal rules in your area? How about a propane tank? Where are you going to put it? You want to use propane tanks instead of natural gas? You're going to put them above ground, underground? Do we have setbacks from property line? Generator location rules. The generator itself has to be 10 feet away from any propane tanks, for example. The generator has to be 5 feet away from any building openings. And that is any part of that generator has to be at least 5 feet away from any building openings. You need to be 5 feet below any overhangs or decks. You have to watch again, like I said, for the property line setbacks. You got to be aware of the noise limitations, and there can be air quality regulations limiting these exercise times. So here's a 24 kW Generac. This is an optional standby system here, and you can see the base was prepared. There's a sand or stone base underneath the precast base, and then you have your electric and your fuel coming from the building. Now, in this situation here, we have this CSST. It's corrugated stainless steel tubing, and it's a flexible gas line that was invented. Actually, it was invented in Japan. And this system here, I have at the present time, I have 10 grandkids, and I can tell you that if we had all 10 grandkids over at Easter or something like that, and they're running around the yard looking for hidden Easter eggs, I can tell you right now that this electric line and this gas line do not stand a chance. They will not survive these kids running around. They will jump on them. They'll use them as swings. They'll trip over them and all that. So we cannot do an installation like this. So I had a class the other night, and I asked the guys, what are you going to do in this situation? Because I know you would not do this. So some of them said I would definitely run the fuel and the electric underground. Other guys came up with creative ideas. One guy wanted to put decorative rocks around the area and build it up so that they wouldn't be able to stand on the electric and the gas line like that. So they come up with some interesting solutions to this problem. But point of the story is we cannot leave this installation in this manner. At that same job site, here's a picture of the load shedding panel. You'll see that your primary loads on that load shedding panel are going to be your HVAC. Then after that, you have load 1, 2, 3, 4, for example. You might throw in the electric range. You might throw in the electric water heater, things like that. So if the AC is not running, these other loads will be able to kick in. That's just a brief explanation of load shedding. The advantage of the load shedding is that it keeps the size of the generator down. Here's our generator overcurrent protected device. It's behind a locked door, and we'll talk a little bit later, but this cannot serve as that readily accessible emergency shutoff for the first responders. Now, if need be, they would get that little door open, but they shouldn't have to go through that trouble. Second example here, this is at my own double wide. It's a 20 kW Kohler. Again, this is set on a stone base, and then the precast form is set on there, and then the generator is secured to it. Here's the trench from my double wide over to the location for the electric and the gas. Do we need one trench or two? Okay, the consensus seems to be that we could do this with one trench, as I did at my place. But you've got to provide separation between the gas line and the electric lines. Well, how much separation, Rich? I don't know what your municipality and what your inspector and what your area is going to require. It may be 6 inches, it may be 12 inches, it may be different elevations and a horizontal separation. So I don't know what your rules are, but you better check them out before you install the wrong way. That is for certain. But your electric utilities, like the electric utilities in our area, when they take a trench to a house, they'll put the gas, the natural gas line, and the electric lines in the same trench. Again, they have their separation. The utility has their own rules for separation. And then the plumbing and the water, they go into a different trench. So the utility puts them in the same trench, the fuel and the gas, and the as well as the electric. So we could do the same thing, but pay attention to your separation rules. In this picture here, this is the regulator coming off of the back of my unit, and that rebar, you do not have to drive a ground rod and ground these generators. These are not separately derived systems. 99% of them are not separately derived systems. So that's just there for a little bit of support. And it's important to follow the manufacturer's recommendations on this, the fuel line coming off. It can't come off and hit a 90, for example. It's got to come off straight. Can't be half inch. It's got to be 3/4, things like that. Make sure you follow the manufacturer's instructions. And in my case, I had a gas, propane company rather, do the propane installation and all that. And you have to watch what they do also. Make sure that they're following the manufacturer's rules. And then coming off the bottom of the regulator is a vent line that surfaces over by the propane tanks. So do we need two conduits or one here? Well, I have two conduits that ran to this unit. It called for the control wiring in one conduit and the power wiring in another. But they have new cables out now that are able to be direct buried, and they'll have both the power and the control in one cable. So again, follow the manufacturer's instructions. Here's the two propane tanks at my double wide there. I was talking to a friend of mine, Mitch Swirsky, the other day, and he said, "Yeah, Rich, those propane tanks are expensive. It's like $2,200 for two of them." So I was very curious. I didn't know I paid that much, so I checked it out, and I did pay $1,900 to purchase these two tanks. They used to rent them, but this particular company here does not rent them anymore. You have to buy the tanks. They wanted me to buy three. I said, look, I'm already doing enough with two tanks, and the two tanks have been serving me well. Even one time when the generator had a run for 2.5, 3 days, I still had plenty of propane. And also, this propane is connected up to the range in my kitchen, so we use the propane for that also. All right, generally, these propane tanks have to be located at least 10 feet away from any sources of ignition. All right, so name the sources that are here. All right, well, you can see coming up, we have the main power and the solar PV disconnects. We have this HVAC split unit behind the fence. That's a source of ignition. We have the range vent up on the wall. That is a source of ignition. And then we have the propane tanks location themselves. So you've got to be 10 feet away from all those three items, for example, and whatever else you run into. But they also have to be 10 feet away from the generator itself, another source of ignition. So some design considerations here. We're going to select the type of generator needed. It's going to be portable, stationary, indoor, outdoor. Well, today's generators we're talking about are going to be outdoor. Noise limitations, the decibel limitations may be set by the municipality. Noise abatement regulations can vary. When I put my unit in, I was a little bit worried about the noise and the neighbors, but my neighbor's lawnmower is louder than my generator, so I'm not worried about it. Sound absorption, if you do have to lower the dB, can be accomplished in a couple different ways. They sell soundproof sheds, they sell exhaust silencers, they sell acoustic panels, and this is a problem that had to be addressed. For example, I remember telling you, I told you a couple of times, I did some electric inspections after Hurricane Sandy in New Jersey. And after that hurricane, you'd be surprised how many generators went in. And so they have to meet these different rules from the municipality. Automatic versus manual switching of standby generators. Well, if you choose to go this portable generator route, who's going to connect up this portable generator? Who's the person with the brains who designed the connection scheme in the first place? Well, the designer of this back-fed connection, the person with the brains that did the design, is that person going to be there when it's time to connect the generator during a power outage? My nephew wanted me to help him set up a portable generator and a back feed into the building. I said, I'm not doing it. I'm just not doing it. I'm a proponent of automatic switching. Here is a typical wire diagram. It is impossible to connect the generator to the utility lines if you have the correct setup in the first place. It's, as it says there, it's a very important life safety issue, and there are some inexpensive solutions. But here on the left, we have the utility transformer, then we feed the meter on our house, then we have the main disconnect, and then through a double throw disconnect switch, this switch would only put in the utility and not connect the generator, or vice versa. When we switch that disconnect switch, we will put in the generator, but we will disconnect from the utility. And there's a pictorial on the right-hand side. Bonding coming up. But you're going to see that these generators, if we switch the neutral, that means it's a separately derived system. Well, we're not switching the neutral in these backyard Kohler and Generac generators. And when you don't switch the neutral, it equals nothing more than just a piece of electrical equipment in a branch circuit with regards to the grounding, and the equipment grounding conductor will take care of that. But that's what 99% of these setups are for these backyard generators. The transfer equipment, the code says, must be suitable for the use intended. That means both in type and in what type of load it has to interrupt or transfer. So transfer must prevent inadvertent connection of the normal and alternate sources of electric supply. In other words, this generator that you cannot connect up can't be able to backfeed to the utility lines. Your utility makes the electricity, and then they transfer it many, many miles. And as it's going, it's being stepped up to a higher voltage. And then as the voltage goes up, the current comes down. Then you have small wires for the transmission. Then as this electricity gets close to your house, it starts to get transferred back down to a lower voltage. It comes down from 13.2 down to, say, 480. Then it comes from 480 down to 240. And then finally, at your house, you have a 240, a 120, 240 feed. Well, the voltage came way down, and guess what? The wires are getting heavier because they're carrying more current, like 100 amps or 200 amps for a 200 amp service. So the transfer switch is required by that section 702.5 for all optional standby systems, except where conditions of supervision ensure that only qualified persons service the installation, and where the normal supply is physically isolated by a lockable disconnecting means, or by disconnection of the normal supply conductors. Well, I don't know of many homeowners that could fit that qualification. A qualified person, according to the National Electrical Code, is somebody who could do this installation electrically and mechanically with their eyes closed, but they also know the safety requirements and how people could get in trouble or get hurt or get killed. That's what makes a qualified person. So I don't recommend that the homeowner be allowed to do their own transfer. But if they do it, I'll be showing you the safe way to do it coming up. Locating this stationary generator, again, minimum 5 feet away from all these items, an operable window, a door, an air conditioner, through the wall air conditioner, a dryer vent, anything like that. Minimum 5, and that's not much to ask for, but it's got to be minimum 5 feet away from all these items. How about sizing the generator in the first place? What's the factors? Well, you got to know the nature of the required load. What are the financial considerations of the owner? You might run into an owner who says, I don't care, do the whole house, throw a 54 kW, water-cooled diesel generator. You might, and you will run into customers like that. So what are the financial considerations of the owner? Convenience of the transfer scheme. Do you want automatic or do you want manual? Well, I wasn't going to do with anything less than automatic. I want my generator to turn on even if I'm not even home. How about the location and the distance from the building? Well, the customer I talked to yesterday, she doesn't want the generator to be visible. She wants it hidden behind the pine trees 200 feet down on her property. How about fuel type? Are you going to use gasoline for portables? Naturally, but do you have any? Is it fresh gas? Do you have enough of it? How about fuel for permanent installs? Are you going to use natural gas or are you going to use propane tanks like I did? How about the system capacity? The calculations of the load for this standby source shall be made in accordance with Article 220 or by another approved method. Well, who does the approving? It could be some AHJ, it could be the municipality, it could be the township rules, all right, some other way that they'll approve how you calculate the load. And some townships do that. They give you a way to calculate the load on the generator to help out the homeowners in their township. Can the electric utility help? Sure. They can tell you what the historical use is of that property. I don't agree with that because if they give you the historical use for one couple and then that couple moves out and the new family moves in and has 5 kids, well, it's a whole different load requirement. So I'm not too keen on that utility measurement helping you out, but it's allowed in the code book. Is it okay to just turn on every possible load there is in the building and measure with an amp clamp meter? Why not? That's what I say. But I'll have people that'll write in and say, Rich, I don't know if that's too good of an idea because. And if they do, I'll let you know in the next session what they. Okay, it's now time for the middle 8, where I'm going to answer a couple questions from the previous weeks. One thing I had a question on. Somebody wanted to know what a factory tie was. Well, this is a factory handle tie. Okay, when you have a 2-pole breaker, a double pole breaker. Okay, this here factory handle tie comes from the factory. This is not something you make. You put a 6-penny nail through or a piece of 12-gauge copper through 2 handles and try to tie it together. No, this is a factory handle tie. This is what you want to use. It's the type of breaker you want to use. Other question I had was how to strip wire. Look, this is a wire stripper. Okay, it says right on it, wire stripper. I see guys trying to strip wire using their side cutters or diagonal cutters. Don't do that. They're not made for stripping wire, and what you end up doing is weakening the conductor because you're stripping it the wrong way. Get yourself a pair of wire strippers. Okay, these here. Oh, there's some free advertising for Klein. Okay, get yourself a nice set of Klein wire strippers. The other thing is, you guys want to know about stripping the wire. Well, there's a wire strip gauge right on the back of the receptacle. The strip gauge there that tells you how much to strip off. Now, I always strip off just a tiny bit more because I think that the strip gauge on the receptacle itself is just a little too stingy there. And what else? Oh, one last thing. This weatherhead. Somebody wanted to point out that when you bring your service cable out of this weatherhead, you can't leave 8 inches. Okay, it's not enough. Our local utility here outside in the Philadelphia area it requires a minimum of 3 feet. Can you leave 4 feet? Go ahead. Can you leave 5 feet? Yes. But leave the utility guy something to work with if he's making the connections. Okay. Now, some municipalities, the electrician, the electrical contractor, is allowed to make the connections, and you have to follow the electric utility rules. It used to be with Philadelphia Electric that no electrician was allowed to make the permanent connections. These days, that was back in the 80s and 90s. Okay, but now these days here, the electricians, electrical contractors are allowed to make their own taps. So, but you still got to follow the electric utility rules. I think that's all I had from the middle 8. If anything else pops up, I'll cover it in the next video. All right, so getting back to these generators, before the whole building generator was installed, this is what you had. You had a meter, you had an overhead service or an underground service, you have a main disconnect, and you have a distribution panel, and then you're going out to your different loads. Well, just replace this main disconnect with a whole house transfer switch. And you'll see that this, whether it's a main disconnect or the whole house transfer switch, this is where your grounding and bonding originates. Okay, you have to come out of this main disconnect or this whole house transfer switch and go to your ground rod. Or if you had building steel in some type of dwelling unit, that would serve as the grounding electrode also. You would come out of your main disconnect to go to your water pipe ground. If it's a metallic water pipe coming into the building, then you would come out of here also, like I said, from the main disconnect. This distribution panel here is already wired up as a sub panel. Okay, it comes off of a sub feeder. We call this a sub panel. Even though the word sub panel is not in the National Electrical Code Book, we know what it is. And in here, in this sub panel, the grounds and neutrals are separated. The grounds are bonded to the can. The neutrals are on what's called a floating bar. They are not connected to the can. So with this, let me go back for a second here before I forget anything else. Oh, when you put a whole house transfer switch or a main disconnect here, don't forget you need, let's say this is a 12240 installation. You need, coming from the main to this sub panel, you need 4 conductors. You need 2 hots, 1 neutral, the grounded conductor, 2 hots, 1 neutral, and the concentric neutral. So you're going to install SER cable, or like I said, 4 conductors between these 2 panels. There are other things, but you should really attend my 4-hour Zoom or 8-hour real life class to get all of this information and get your questions answered. There's only so much I could do in a half hour. Your transfer equipment requirements, again, if it was NEC Article 700 emergency, like at a hospital, that transfer must be automatic. If it's an office building and they need lights and they need elevators to get people out of buildings and things like that, that transfer must be automatic. For your backyard Kohler and Generac generators, Article 702, optional standby, the transfer can be automatic or manual. The transfer time constraints for a hospital, you have, you might have a person on an operating table, and if the utility goes down, there's battery backup UPS systems that just immediately kick in. But the generator itself has 10 seconds to be called upon, fired up, close its transfer switch, and be providing full power in 10 seconds. If it's illegally required, where we want to get people out of that office building, you have 60 seconds max to fire up that generator, get it up to full speed, and kick in, and then put on some lights or power up some elevators, etc. Article 702, the subject of today's vlog, is optional standby, and the transfer can happen whenever. Nobody's concerned about it. So here's a manual transfer switch, and you can see here that we have the utility main breaker on the left, top left. We have the generator main breaker on the top right. Well, this slide plate will only allow one of these two breakers in at a time. So if we flip it over and block the utility, then we could kick on our generator. If we turn our generator off, slide this slide bar back over, then we can only put in the utility breaker. So that's a good way to keep the two systems separate at all times. And here you have a nice, I like these. The A and B will tell you the amperage on this two phases that are coming in, phase A and phase B. This system here, there's no error with this type either. There's a slide plate, and the main breaker allows the utility to be connected, and it blocks the generator. So this particular one then, if you turn off your main breaker, it's hard to see, I understand that. But if you turn your main breaker off and then slide this bar back up, okay, that will block the main breaker, and it will allow this two-pole 60 amp or two-pole 60 amp breaker to be turned on. So there's no possibility of messing up with that either. Sample load shedding scheme, as I talked to you before. All right, probably the main and most important items to be transferred over to generator power is the HVAC, whether it's air conditioning in the summer or heating in the winter. That's if you have a house with HVAC, both ways that way. If you have a house that only has a heater, okay, well then it's not going to come in play in the summertime. All right. And then these other loads, load 1, 2, 3, and 4, can be selected according to what the homeowner wants. But if we only put in certain loads at one time, well then we can use a smaller generator. We don't have to go with a 54 kW. We could do with a 22 or a 20 or even a 15, as long as you do your homework and do your calculated load. And then the load shedding scheme will help you lower the kW needed for that building. All right, let's talk a little bit about grounding and bonding. A ground rod is generally not necessary for that backyard Kohler generator. And what's this ground rod for anyway? Well, the ground rod, I told you before, there's two types of electricity. The first kind is the kind that God makes, and that's lightning. And the second kind is what man makes, and that comes from the utility and from the transformer to your house, okay? So the ground rod is mainly for lightning strikes, and we want to channel them to ground rather than let it run rampant through a building or run rampant through a house. And as a matter of fact, in the old days, you older guys like Joe Coyne, you would refer to that as a lightning rod. All right, so Generally, you're not going to drive a ground rod just because you're putting a generator in somebody's backyard. If you put a radio or a boom box in your backyard and plug it into an extension cord, you wouldn't put in a ground rod for that either, okay? So the equipment grounding conductor takes care of grounding that generator. So don't get carried away with these ground rods. 99% of these optional standby generators I mentioned do not have a switched neutral. So that means they're not separately derived systems. The installer has to make sure that the ground and neutral are separated at the generator and kept separated. Well, when you rent a generator from a rental company, you have to be careful that the ground and the neutral are bonded or not bonded, depending on the way you're using it. But when you buy these Kohlers and these Generacs, they 99% of the time will come with the ground and neutral unbonded at the generator, and that's what we want. You want that. So like I said, driving a ground rod at a non-separately dry system is not required unless the utility says something, or the manufacturer says something, or your township says something. Okay, you got to be very aware of the rules and what you have to do and what you don't have to do. But I'm telling you, according to the National Electrical Code, that you do not have to provide a ground rod at every generator. Okay, that is a little bit about the home generators. One last thing I want to talk about is gasoline and using these portable generators and trying to backfeed them. And there are people that, you know, after a storm and loss of electricity and all that, you go into a Home Depot or Lowe's and you go into that 240 volt 30 amp aisle, and it looks like a bomb hit it because everything's laying on the floor, the shelves are empty, and people have raided all the 30 amp 240 volt equipment. I do not recommend, nor does the National Electrical Code allow you to backfeed a portable generator into a regular receptacle or a 30 amp dryer receptacle. You don't do it, because to do that you've got to make a cord with two male ends, and you're only asking for trouble. It's a dangerous situation. So always do it with a bona fide automatic or manual transfer switch, something that's made for that operation. The other thing is these portable generators used in an emergency situation. I know my son and his buddy, they were hooking one up in the middle of August and throwing back a couple beers and this and that and having a good time and showing me how it works and how it connects up and everything. Well, that's great. You know, that's great that you could wheel that around to the other side of the house in the middle of August. But what about the February 15th in the middle of the night with 24 inches of snow in Pennsylvania? It's not too easy to get that generator over to the other side of the house and connect it up and this and that and do what you have to do. The other thing is, at this 2 o'clock in the morning, February 15th, if you got the generator over there, is there gas in it? Oh, well, I have some gas in the garage. That's great. Is the gas in the garage fresh? Or you're going to be out there pulling your guts on that starter rope and then the thing not firing up? You've all been there. You know what it feels like. So what about, yeah, I do have gas in it, Rich. And yeah, I do have an extra gallon or two of gas in my garage. So yeah, I could handle that. Really? Okay, that's fine. Or could you do like a guy that I know in Maryland, that he had the generator running on his wooden deck, this portable generator on wheels. He had it running on his deck. And then it ran out and shuts down. And well, he goes out with this fresh gas, pours the gas into the generator, overfills it, it overflows, and now it's on his pants leg and all that, and boom, flares up. Now he's on fire running around his backyard with his pants on fire. All right, that's not what you want. You don't want to put yourself in that position. How many homes are lost every year? I'll give you an example. 14 homes a year, 14 dwelling units, houses, burned to the ground every year because of people trying to do the fry this turkey in some oil. So it's the same thing with the generators. How many houses are lost every year because people want to try to refill a hot machine with gasoline and handle their backup generator that way? So I don't recommend that at all. I always recommend a bona fide transfer switch. All right, so there's a little bit, there's a lot to do with these generators. There's a lot to know with these generators. Feel free to send questions, and I'll give you, in the future, I'm going to recommend a book. People are asking me about what book they could buy that will help them understand electricity around the dwelling units, and I'll be giving you that information at a future vlog. But other than that, that's it for today. Um, Emergency generators, standby generators. Van Wert out.